your seat.
Which one?
Or you're
That seat?
with our group, or you're sitting with your group. Okay.
That's what they told me to do.
So what do you think?
It's like 2 rulers.
You smell that?
Oh my gosh.
You smell that? I smell Melissa
We just didn't
winning.
see the other ruler.
Melissa what?
Winning.
Winning.
Thank you
She
very
got
much.
a cookie. Okay, fellas, so what do you think we can do with this data now that we've got?
I mean, you can like, you could definitely know how to put like dots on a line graph, right? And know where they would go, probably.
Can we make a
Doesn't
connection?
the line graph always have time in it?
I think it's supposed to be like this. You're supposed to have an X on the. I mean, we were doing like a circle plot.
What are you looking
Or like, you know, the bar graphs, you know,
Yeah.
they have the circle.
Like,
It's
but
a
they
lot
have
like,
like January,
it's a lot like that
February,
because
like
normally we would
March,
see like the
February.
X on it.
How much in between?
But we're doing a bar like thing, we're doing like a
So
circle.
about halfway in between.
So that's why you see the circles up there. It's completely different.
Right, so how'd you figure that out right there?
It's halfway between.
So we are doing a pie chart.
No, it's different because we're putting the pieces of the pie like into line to show the difference
Good.
that it changes. Because like when you think about a pie and it goes into like the different slices, we're all part of the
Man.
yeah. I was, yeah, it was
Are
like-
you smarter than a fifth grader?
No, I'm
Yes, you
saying
are.
no. I just like I eat a lot of pie, so it's not. Yeah.
So the bigger pieces of the pie,
Are the
bigger numbers.
bigger parts in the line?
When you
Man.
cut it
Up
up, if
higher.
the apple's not in one piece, it'll be in the other.
It's up higher on the line.
jeez.
Yeah.
Yeah.
But then how the heck do you take the derivative of that?
Fellas, what's the derivative?
You guys didn't even
We're almost done.
class.
Yeah.
I think everyone's got
Sure.
Wow.
Oh, that person's 200 centimeters tall. I told you.
What? I don't even know. They're gonna break your hands.
Okay, so Brandon, you just said that, they're gonna break their hands, and Adrian, you said they're too tall. What do you mean by that? Now look at that graph. Why did you say they were too tall?
They're almost 200 centimeters.
Okay, what about them is almost 200 centimeters?
Their height.
Their height, okay? Now what were we looking for? What was the most important thing here? Look back to your picture on the first page.
The readers.
Right, their reach. So the person that is 200 centimeters tall, what is approximately their reach?
140.
Okay. So what does that tell you?
They have really short arms.
Okay, what else does that tell you about riding the ride?
Oh, it's okay.
You okay?
They be okay? Okay.
So our question was, can the Tin Man ride the ride? Hey, it's you. So what do you
Where's your
think?
metal suit?
The Tin Man is 180 centimeters tall.
That's scary.
What
So
about his
Katie, what was
reach?
our maximum height? Or what was our maximum reach? What was the height of the tunnel?
150.
Right.
Okay, so how can we represent that on these graphs? Okay, what kind of line?
Vertical line?
A vertical line? Kevin, what do you think? Vertical line on the graph to represent the height you have to go under the tunnel?
Well, you said we need to know the reach, so I guess we need to first figure out the reach of the Tin Man.
Okay, but what about overall? What's the overall height of the tunnel?
150 centimeters.
Right, so how can we put that on this graph? Where the cutoff would be, where that,
Oh, don't say cutoff.
where the top of the tunnel would be.
So that would be a reach of 150.
Okay,
Right.
so how would we put that on this graph?
So draw a line, a straight line across 150.
Across,
150 reach.
okay, like that?
Yeah.
Okay, exactly. It's kind of like where the roof of the tunnel would be. Okay, good connection, Brandon. All right, so what did you all find in your groups? Okay, so looking at these graphs, can anybody point out anything that maybe looks similar, maybe looks wrong? What's different between them?
Two dots on that one's really, really short.
Okay, so what do you think happened there?
They're really, really much.
Okay, well, look around.
Really long arms.
Did anybody
Really long
look
arms,
really,
yeah.
really short here?
No, it's
She
like
didn't.
magic.
No. Okay, so what do you think happened, Josh?
Ooh.
Did you see anybody really, really short here?
I mean, not really.
Okay.
We're all about the same height, really.
Okay, so what do you think happened with these two dots right here?
Why are those graphs like that?
Why are they over here?
Well, I remember I put my point over there, and I measured myself that it said 80 on the ruler over there. So I don't know, maybe everybody else just messed up somehow.
Okay, so you think there's some sort of error there?
Yeah,
And-
because I mean, I know I saw 80 on the ruler, so obviously, I mean, everybody else kind of, maybe they just weren't reading it correctly, or they read it too high.
I think everyone else is cheating.
Think everyone else is cheating?
Yeah.
What do you mean?
I think somebody got on someone's shoulders when they went up there.
Or maybe they just
Okay.
wanted, there were like some kids like wanted to be taller than other kids, so like I don't know, maybe that was part of it. But I know I saw 80 and we were pretty thorough and stuff like that. So it said 80 on the ruler, so I don't know why else there would have been a problem.
Let's see what-
The Tin Man told me there's two rulers there, though.
Oh, like in the, is it like in the first part?
Yeah, that's what he said.
Oh, okay.
Okay, so there was some sort of error in our calculation that we
So
did.
maybe I didn't,
I didn't see
maybe I
the
Right.
second ruler.
maybe I didn't put the.
So you
I didn't
didn't
think-
start right here
Oh.
and stand up to here, right?
Right, I thought
Stood
since the
at the
ruler
floor.
said 80, that it was 80 centimeters tall.
Okay,
Okay, now that makes sense.
okay, so some of us had some error miscalculation
Okay.
on our height,
I'm
right?
sorry, I saw 80 and thought it was 80.
2 minutes. 2 minutes.
Okay, so then,
Do we want to fast forward?
yeah, I'm just gonna move you guys.
So now, we've decided that the Tin Man can ride because he's only 180 centimeters, and we can see that that comes up to about 140 on the reach. But what if he was taller? What if it was, how tall can we go and it still be safe to ride? How can we figure that out?
Wherever you touch the line.
That's tall as the tunnel.
Okay, so
You
let's
can
look at
put-
this graph. Yes,
You can put someone on the ride, and if they're too tall, they won't make it through the tunnel.
well, that wouldn't be good, right? Because what if that was somebody you knew, right?
Put a scarecrow on there.
Or you could put up you could use the yardsticks that we were using, and like tape the yardsticks in the ride, and if
To
it
the
got
seat.
chopped off.
Okay, why don't you come up here to the graph and show us how we would do that with just the graph, if we weren't gonna actually ride the ride. Come on up, Josh.
Okay.
Matthew, why don't you come up too, help out?
Yeah, March 15.
Okay, so what do you see going on here? Think about what you wanna do with putting the yardsticks up.
So while they're working on that, you all think about how would you take the data you've got and determine
Don't see
what's
any
the
pattern.
safest ride or safest height to ride this ride?
Sort of a little, but I mean,
How can you
Okay, so
take
what
the
kind
shortest
of-
person
What kind of graphs
and
do you know
expand
about?
that
Okay, so Stephen just did that?
a height that we don't have?
What's that gonna look like? What kind of graphs do you all know about that we could maybe make?
Do you see it?
I know it's a bar graph earlier,
The dots
the
up
pie
there.
chart. What other kind of graphs do you know?